Great job! We did it! We have gone through many chapters about fundamental X.509 public key infrastructures and have reached the last lesson with a summary of what we have learned and an outlook onto other applications of X.509 PKIs not yet discussed in this course. In this course, we got to understand X.509 public key infrastructures as systems capable of constructing and providing trust into the authenticity of public keys that can then be used for various cryptographic applications such as encryption or authentication. In X.509 PKIs, the cryptographic public keys are embedded within X.509 certificates, which are issued by certificate authorities to be valid for a limited lifetime, and with the certificates being cryptographically signed by the issuing certificate authority. If the certificate authority can be trusted with these certificates to accurately bind the public keys to the owning end entities, then these X.509 PKIs are indeed capable of constructing and providing trust into the authenticity of the public keys contained in the X.509 certificates. Key to X.509 PKIs is that the trust model involved is transitive, which allows an end entity to only trust a specific root CA and allowing for the certificate authorities actually issuing the certificates to be decentralized, which is a flexibility that allows for X.509 PKIs to be very versatile in the architecture and can make it a fit for various use cases and organizational structures. The theory of this course then provided a solid understanding of how the two-tier X.509 PKI presented on this slide emerges as an architectural recommendation for X.509 PKIs, and the overall course then culminated into an implementation of such a two-tier X.509 PKI with OpenSSL, with the constructed X.509 PKI then used to secure the initially insecure emails exchanged between Alice and Bob to a point where the emails were signed then encrypted, and with this providing authenticity and confidentiality to the emails exchanged. Securing the exchange of emails is just one application of X.509 PKIs, with the flexibility of the architecture of X.509 PKIs actually allowing for many other applications besides the secure exchange of emails. A first different application of X.509 PKIs is code signing, which is essentially the process of providing cryptographic digital signatures to binaries and applications, and with these cryptographic digital signatures then allowing for the binaries and applications to then be verified for authenticity before the binaries and applications would be installed or run on a target system. This requires to provide authors and manufacturers of binaries and applications to be provided with X.509 certificates that can be used to create digital signatures, and to install the corresponding trusted root CA certificates on the systems that ultimately will install or run the binaries and applications. The verification of the digital signatures provided on the binaries and applications is then the very same cryptographic digital signature verification as we have seen and discussed it many times during this course as well. A second interesting application of X.509 PKIs is Secure Boot, which itself is an application of code signing and is a process to ensure that hardware devices like servers, laptops or smartphones only boot software that is trusted by the hardware manufacturer. This involves the signing and verification of each piece of software involved in the booting process of the hardware device, starting all the way down with the first hardware drivers initializing the hardware and going all the way up to the final operating system loaded. This is clearly an application of code signing, but additionally makes use of special purpose tamper-resistant hardware elements on the devices, where these devices have the root CA certificates or elements of it burned in without a way to ever modify it again after the initial burn. Surely you must have wondered by now how I can keep going through a course of X.509 PKIs without ever mentioning the Transport Layer Security Protocol TLS. And indeed, TLS is a major application of X.509 PKIs and X.509 certificates, where TLS essentially establishes a secure communication channel from an insecure communication channel between a client and a server that have never met before. For this, TLS as a protocol makes heavy use of all the cryptographic primitives and mechanisms introduced in the Fundamental Cryptography course, as well as the semantics of X.509 PKIs and X.509 certificates as presented in this course. A classic day-to-day use case of TLS is browsing the web, like for example Alice using the browser on her laptop to access her bank for e-banking purposes, which relies on modern browsers to have trust stores containing hundreds of X.509 root CA certificates that are used to construct the trust into the public keys, from which the cryptographic keying material is derived to secure the data exchanged between the client and the server. As already mentioned, TLS is a key application of X.509 PKIs, and on top also a very beautiful application of many fundamental cryptographic primitives and mechanisms, and as such I have decided to not just demonstrate TLS as part of this X.509 PKI course, but to make TLS the subject of its own dedicated course. With this, I reached the end of this course about X.509 public key infrastructures, and I hope that you could solidify your understanding of X.509 PKIs as a system that allows for the construction of trust into public keys used for cryptographic purposes. I hope you enjoyed the course. I wish you all the best, and I hope to see you in another course another day. Goodbye.